All right, first things first, we start with what an empirical formula is. This is going to be the lowest whole number ratio formula. For any compound. Specifically, we start with something like CH. Its lowest whole numbers are ones, right? In theory, we could have a multiple of that, right, as the actual compound. This would be considered a molecular formula. And this would be its empirical counterpart. One of those has the lowest whole numbers, and the other is a multiple of those particular empirical numbers. In order to calculate an empirical formula, we need a percent composition or mass information about elements within a compound. So we're either going to start with the percent compositions you practiced with on Friday. One of the things I will do is you were supposed to do your work on a separate sheet of paper on Friday, right? We did that, right? I'm going to put an assignment up on Canvas by the end of class today for you to just submit that work because I want to see the work. I don't really care about your answers. I care about your work, how that works. So we're going to start with our percent compositions, or we can start with masses, also known as mass components. And we're going to do one example of each different problem. We're going to use the percentage method, probably the most common, but really just the difference between these two is that this one has one extra step. Otherwise, the steps are completely the same. Weird with empirical/molecular. Cool. Okay. So let's look at an example. And 21.9% hydrogen. Okay. This is the extra step I was talking about. The first step we're going to do whenever we're trying to consider or trying to figure out what an empirical formula is to convert percents to grams. We're just going to change the variable. So 78.1% B becomes 78.1 grams of B. Same for the hydrogen. Well, that's step one. Take your percentages, change the percent sign to a gram. All right, step two. Convert grams to moles. How do we do that? Cool. Where do we get those conversion factors from? Periodic table. So we're going to use molar masses from the periodic table. Okay. So for boron, what are the two that we can write? Go ahead and look. So grams over 1 mole, or okay, for hydrogen we can do the same. Okay, so we're going to do both conversions. To go from grams to moles, should I use the left or the right? The one on the right. So I'm going to put the grams on the bottom and the mole on the top. For the hydrogen, I'm going to do the same thing. I'm going to put the mole on the top. Going to multiply across. Divide by what's on the bottom. Definitely going to need your calculator to do the math. Come on. Calculators every day. Does this happen?
7.33 moles.
How about this one?
21.7.
Okay. What?
21.
Oh. My bad. That makes sense. Okay. Next step is going to be to divide both of these numbers of moles by the smaller of the numbers. So you could have up to 3 or 4 different molecules or atoms that you're working with, right? Whatever the smallest of these molar amounts is the one that everything gets divided by. So can I erase step 1? Is everybody cool with this part of the board? Okay. So divide all, including itself, molar amounts by the smallest molar amount. Okay, so which one's smaller, top or bottom? The number of moles of boron is the smaller of the two numbers. So I'm going to divide both numbers by that number. The other one as well. .7 divided by 7.22 should be about 3, give or take. Say again?
Yeah, 3.005.
No. What we're looking for is the nearest whole number. Okay? These are both whole numbers. So this gives us what our formula should be. So step 4 is to write a formula with whole numbers. And we're going to talk about some of the things that might happen. But for now, we've got a B with 1, and then we've got H, 3. How does that change? Do we ever show ones? No. Okay. So that's the method, general method, for calculating an empirical formula from percentage compositions or mass amounts. Okay, let's do another one. I'm gonna do a deliberate one. Okay. Can I erase? So now we're going to do a slightly different version. And there's a step we'll leave out, but we're going to see that we're going to have to do something different. Slightly different. All right, so this one is a 10.150 gram sample is found to contain only phosphorus and oxygen. If 4.43 okay. All right, so the original version of our empirical formulas required percentages. But our first step was just to take the percentage sign and make it a gram sign, right? So couldn't we theoretically just start with grams and move throughout the whole process? Yes, is the answer, okay? So in this particular sample, we're given this, and we can just skip to step 2. We don't have to assume percentages become grams. We're just going to write out what the grams are going to be. So if this much of this sample is phosphorus, what is going to be the content of the oxygen?
5.717.
Thank you. How'd you get that, Carter?
Minus from the
You just subtracted from the 10 grams, okay? All right, step 2 is to convert grams to moles. So we need our molar masses. We're going to set up our 2 equations. All right, what goes here?
7.9737.
Thank you, ma'am. Grams of phosphorus underneath 1 mole. We got that from the periodic table. I didn't write out the conversion factors today. Are we feeling okay about it? Hopefully you're recognizing where the numbers are coming from a little bit quicker. Not a big deal. If you don't, what should you have done first?
Like the conversion factor.
Right. If you need to do that, you do that. And don't worry about it. Okay, down here, cross them off, multiply across. Oops. What?
31.
1431? What about this one? All right, let's use some number sense. Which one's smaller? Top or bottom? The one on top. So step 3 says to divide all molar amounts, that includes the one that you're using, all molar amounts by the smallest one. So we're going to do 0.1431 over 0.1431. And this is going to get you 1 mole of P. And we're going to do 0.3573, 0.1431. What are we going to get there?
2.49.
Is that what she said? 2.497? Okay. Our last step. Write a formula. Is that a valid formula?
Has to be a whole number.
No decimals in my chemical formulas. What can I do to get rid of the decimal?
Times phosphorus by 2.
Couldn't we multiply everything by 2 to get these numbers to whole numbers? Let's multiply everything by 2, including the 2.5. P2O5. Okay. So that was an example of non-percentage type of problem, plus what we can do to get rid of like a 2.5. Okay. What if you had that? What would you multiply everything by? Yeah. You see what I'm saying? So you may come out with like decimal forms of common fractions. You might get, what do you multiply by? Okay, you get 5. Treat your fractions. You should not come out with numbers that are like make no sense, right? You get a number like this and you must have done something wrong. Or you carried a decimal wrong, or something didn't come out right. Or maybe you didn't convert something correctly, use the wrong value, whatever it might be, okay? You shouldn't get numbers like this. You should get numbers that are common, like fraction. Decimals.
So you would multiply by 3 because it would get you to the next whole
It would get you to the next whole number you could get to. And you would multiply everything by 3, right? Not just this, you multiply everything in that particular problem by 3. Okay. We're going to keep P2O5. And we're going to talk about our very last concept in this section, which is the molecular formulas. Once you have an empirical formula, we can deal in molar masses. If you have a compound to work with, we can talk about its molar mass. I gotta do math real quick. Okay, so first thing, let's say you're given an empirical formula like P2O5, all right? Let's say you're given the information to get an empirical formula. However the problem starts, you need an empirical formula to do anything with a molecular formula. You would be asked, what is the molecular formula if the mass of a compound, molecular compound if you will, is your book also likes to use the unit U. U is shorthand for AMU. And remember that AMU and grams per mole for us are pretty interchangeable. Okay? Okay, so in order to do this, you need an empirical formula. Okay, that's the first step. Whether you're given it or you have to find it, that's step 1. The second step is to find the empirical formula molar mass. Last step, divide. So the last step is to take the molecular mass you're given, divide by the empirical molar mass you calculated in the previous step, and find a ratio. That ratio should again be a whole number. Okay? If it doesn't come out to be a whole number, something's wrong. And it could be with your empirical formula. Right? If you screwed up here, there's going to be a problem down here. So, a lot of times with molecular formula questions, I will ask them in such a way that you can't screw it up. By giving you, hey, here's an empirical formula. What's the molecular mass, or what's the molecular formula if the mass of the molecular compound is this? Okay. Once we have this ratio, the last step is to multiply all subscripts in the empirical formula to get the molecular formula. So let's do this for P2O5. Step 1 was we needed an empirical formula. Do we have it? Yes. Step 2 is to get the mass of the empirical formula. So how do we do that? From Friday. What are we going to do? Yep, we're going to do 2 times P, 5 times O, add them all together. I got 141.9444, double check it. Step 3 is to divide. So we're going to take our given molecular mass, so the 425.833, divide by the 141.94444, all the 4s. When you divide those two, what do you got? 2.99999, which is basically 3. You're hoping for a whole number, so that's good. All right, so then our last step is to take P2O5 and multiply all of the subscripts by 3 to get a molecular formula, P6O15. Okay? Kind of, sort of? Yeah. All right, in your OneNote notebooks is your homework over 7.4. I'm going to give you some time to work on it. There's a few problems. What I want you to do is I want you to do that work on a separate piece of paper to turn in. You can either upload your photos onto OneNote directly, or you can turn in your paper when you're done. It's up to you. Oh, and we haven't set up our OneNote in this class. So, on the left-hand side, remember, you go to class notebooks. So I have to set up a new class notebook because it's a different Canvas class. Listen, I don't make the technology. I just live in it. So when you log into Canvas, underneath today's daily Q, there's a thing that says 7.4 practice. If you click that, it'll lead you through the notebook setup. And once everybody's in there, I'll distribute the homework assignment. And I will remind you, if you want to redo 7.3, make sure you really grasp those molar masses, make sure you understand those percent compositions. It is open to you for as many attempts as you like. Just say when you do it. That's it. Or it's just like there for you to, because it'll give you immediate feedback.
Sorry.
Yeah.
Okay.
Is it this chapter 7?
Sure.
Okay.
I'm not sure why it would be